Today's lesson is the average value of a function. So let's talk about average value, or finding an average when you did it when you were a little kid. If we wanted to find the average quiz score, what that would mean is you would take the quiz scores that you've gotten and add them up. So let's say you got like a 9, an 8, a 5, a 10. 4 different quiz scores. You would add those up, and then you would divide by the number of scores you have taken, how many quizzes you've taken. So this idea is that this part right here of the formula is the sum of everything, the values, the sum of whatever we're dealing with. And down here is the number, that's the symbol for number, of whatever items you're finding. So this kind of structure we're going to see is the same idea for how we work in calculus on these. So this time, the difference is with calculus is numbers aren't just like simple adding it up here. Instead, we have some functions that are doing lots of changes. But let me keep it simple for a second here. Let's just pretend like this is a stock price that's at $100, and the stock has done this. You know, it's not just individual points, but a changing thing that happens throughout it all. So let's say this is it from, the last 10 days or something like this. So starting at 0 to 10 days, this is the stock's gone up and down. If I was to ask you what's the average value of the stock price from time 0 to time 10, what do you think the average price would be after all these ups and downs? I think your guess most likely would be the average is 100. It's gone above 100 and below 100 equally. And so this leads us to this belief that we can find the average of some value, even if it's changing in like a constant line like this. There must be some kind of average. And that average is going to be somewhere between the high and the low point of the graph. And this average, the function actually has to touch that average at some point. So the average we're saying is 100. Well, it has to, at some point, the stock had to have been a value of 100. So it hits here, 100, and at least one time that average is obtained at a specific moment. So how could we actually calculate this in calculus? Maybe the idea of seeing something equally above and below leads you to think about like that signed area or something to do with area. It does branch off from that. So this is what we need to do. We need to add a sum of something here, a sum of values, and divide it by the number of those items. So to add the values, we need to add all of these little, sorry for the shake there, all of these values of the stock price at every instantaneous moment. So what you can do is actually make this into like when we did rectangles and found like a Riemann sum or an integral of adding all of these up. So each rectangle would be a y value, high, f of x value, high, which would tell us the location of that point right there. But then the rectangle also has a dx, which would be finding the area of that rectangle, which is more information than we want because we're only wanting the y values to be added together, like here, just the y coordinates. But if we set this up, we can set up an integral of adding the f of x, all the y values, but we need a dx there. So the change of x from 0 to 10 here. But then that's giving us too much here because we don't want the dx, we just want the y values added up. So we need to get to this part, divide by the number of items. So we're going from 0 to 10 is like the number of items. So we would just divide that by the dx, or the change of x. And the change of x is the difference between 10 to 0, or 10 in this case, 10 minus 0. And what this really represents is the change in x. The change in x value here, which what that does is it cancels out the dx information with this on bottom giving us a result of just a y value. And that y value would be f of something that's not x, because x could represent in general, but a specific x value. And this we call just like f of c. And this would be the average y value. So this back here, this value is the f of c. It would be then at 100. So you can see the structure of this is the same kind of structure as what the original old school formula of finding an average is. It's summing them all up, but then dividing by the amount of values we have. So let's write this as like an official formula in our notes here. So the formula here would be to find the average value of f of x. We'll call the average value is the average y value. Very important to know that's the y value. Would equal, the formula would be finding the sum of the integral from a to b of f of x dx, and then dividing by the dx, which is, we're not going to put dx, we're going to put the difference of the x values, which would be b minus a, top minus bottom, as we always do. So whatever the difference between those are. Now, there's another way to write this formula. So I'll write it another way. You can see it's the same exact formula as this one is, except instead of dividing right here by b minus a, we're going to multiply by 1 over b minus a times the integral like that. It's really the same thing. Instead of dividing, we're just multiplying by there. A key idea that you need to know about this is that what happens with this b minus a, which this is like the dx, the change of the x's, and this is the change of the x's here, is that they cancel. So your original problem, you're plugging in f, and the answer that comes out is f. So for example, what's important about that is, let's say I wanted to find the average, let's say the average velocity. Then I would want the average velocity would be looking for v of c. Then the formula, I would have to put in here something in right here, some function in there, and then divide by b minus a. So the point I'm trying to make is, what function goes in here? Notice that with our formula, if you want the average f value, f is the function that goes in every time. So if you want average of f, the function that gets plugged in is f. The dx's cancel out here, leaving f as the result. Not f prime, not the antiderivative, it's just the same function. So if I want the average velocity, the function that needs to go in here is the velocity function. It's tempting to think that you would put in like, acceleration or something like that. But no, these functions have to match up. That is key. All right, let's get started at some practice.